Okay, talking about slope-intercept form of a line. Slope-intercept form of a line is when you identify slope, and the intercept part stands for the y-intercept, or where the line crosses the y-axis. We use slope-intercept form when we're talking about linear equations. Linear equations are, well, probably the most common equations that you and I would use. We can come up with a linear equation whenever we know a rate, like if you get paid a certain amount per hour, that's a rate, and I can write an equation based on what you get paid per hour. So we're going to graph those, and we're going to write equations of those types of lines. In order to be able to graph them, first thing we need to be able to do is come up with a slope. I've got the definition of slope here. Slope of a non-vertical line. I say non-vertical because vertical is a little bit different. You can still use this to find vertical, but you need to interpret what you get for a result. But the slope of a non-vertical line through points. X1, Y1 means that you just got a first point. The ones don't mean anything other than that's our first point. And then X sub 2, Y sub 2, that means there's your second point. So it's the ratio of the vertical change to the corresponding horizontal change. What does that simply mean? Rise over run. How far up does your line go? How far over? So if I'm on a line, if I go up a certain amount, how far over do I have to go to get back on that line? You're going to get slope equals rise over run, or you simply subtract the y's, put them over, subtract the x's. y2 minus y1. Now it doesn't need to be the second y because, if I told you a point and then another point, I could have easily reversed it. They're on the same line. So it doesn't matter, you just need to be consistent where if you start with one of them, you take the y of that point, subtract the other y, and then you take the x of the starting point and subtract the other x. Some general stuff to look at here. You need to think about lines going left to right like reading a book. So as left to right, when it goes up, it's positive. Goes down negative. Flatland, I wouldn't mind walking on that line. That's a very easy line to walk on. That has a zero slope. And then this is that vertical line here. I definitely would not want to walk on that line. That wouldn't end well. Vertical line has an undefined slope. And we'll show you how you see that mathematically in a little bit here. So, a couple examples. How do you find the slope of a line? Identify the y's, subtract them. Now my y's over here are -1 and 5. So it doesn't matter the order. I can go -1 minus 5, or I can go 5 minus -1. What matters is, when I get to the x's, I have to be consistent. So on this one, on the one on the left, I started with the -1 as my y, so I would have to start with the -8 as my x, and then subtract -2. On the right, had I started with the 5, I would have had to start with the -2 and subtract -8. Now if you do this right, it doesn't matter. On the left, on the top, I get -6. On the bottom, I switch this to plus, I get -6. And -6 over -6 is 1. If I'd have been the person on the right, I would have switched top to plus, got 6. Switched the bottom to plus, got 6. It still got the same slope of 1. So it doesn't matter which y you start with, it's just make sure you start with the x that goes with it on the bottom. I want to pause right here, try this one on your own, see if you can get the right answer, or see what, I think this one's a little bit different, but at least get it set up. Alright, now here's how I would do it. I'd identify my y's. They're 5 and -5. I always like to put the positive one first. So I go 5 minus -5. You've got to make sure that if it's a negative, you're subtracting a negative here. A lot of kids forget to put the negative there. Now if I start with the 5, that means I have to start with the -3. So -3 minus, and then the other one's -3. Well, they're the same things. It was hard to go wrong here. As I simplify, I've got minus minus. So these will be plus plus and plus plus. 5 plus 5 is 10. And -3 plus 3 is 0. And then we've got a bad situation here. When you divide by 0, it's all fun and games until somebody tries to divide by 0. You can't divide by 0. When you have a divide by 0, you put undefined. That would have represented a vertical line. Okay? These points go through a vertical line. I could show that to you. I could sketch a real quick graph here. The first point was at negative 3, 5. So negative 3, 5, that would be 3 left, 1, 2, 3, and 5 up, 1, 2, 3, 4, 5. That would be right here, 3 left, 5 up. And then the second point, reminder here, was negative 3, negative 5. Well, negative 3 is 3 left still, but then the negative 5 is 5 down. And you can see if I connected these, I would end up with, in fact, a vertical line. And vertical lines have undefined slopes. Horizontal has a slope of 0, vertical undefined. Okay. Horizontal would end up the other way. You would have 0 in the numerator on your slope. You'd have something like 0 over 10, and that's okay to do. If I have no money and I divide it amongst 10 people, they get nothing. So I can have 0 on the top. Okay, the slope-intercept formula equation of line is y equals mx plus b, where m is the slope of the line and 0 dash b is the y-intercept. So we got our slope is m, and this last number is your y-intercept, which that'll make sense here in a second. What is the y-intercept? Does every line have a y-intercept? So the y-intercept is, again, where your line crosses the y-axis. Does every line have a y-intercept? Well, almost every line has a y-intercept, except for there's a special type of line that wouldn't have a y-intercept, and that is, again, that vertical line. You know, if I had a grid over here, and then I drew a vertical line somewhere, I could call that 3. This would be the graph of x equals 3, by the way. All the x's are 3. That does not cross the y-axis, so it doesn't have a y-intercept. Does every line have a y-intercept? Vertical lines don't have y-intercepts. Now there is one vertical line that crosses the y-axis, but it crosses everywhere. If I move this line over and put it on the y-axis, it's hitting the y-axis, but it's hitting it all over the place, so it doesn't have a y-intercept. Okay, so what do I do if I give you a slope and a y-intercept? I put a little present over here because this is really a present. I'm going to write this in y equals mx plus b form. That means I need the slope and I need the y-intercept. Well, notice I said the y-intercept is 0, negative 4. Very important to note that on a y-intercept, the x-coordinate is always 0. You need the x to be 0 in order to cross the y-axis. So 0, negative 4 is right down there. Furthermore, if I want to graph this, I think I graph again later, the slope's negative 2. Just a reminder, that means you're going to go down 2 and 1 right. Down 2 and 1 right. I can put a 1 under there, and then I've got my rise over run. Now this problem, I put the present over here because it's really easy. I give you the slope. I give you the y-intercept. You're done. So if you have slope, you have y-intercept. It's really easy to come up with an answer. Number 4, write the equation 4x minus y equals 3/5 in slope-intercept form. Then graph the equation using the slope and y-intercept. Slope-intercept form requires me to get the y alone. So a couple ways to get the y alone here. Most of you, I think, would probably subtract 4x. So you'd end up with negative 4x plus 3 over 5. But you got to be careful, that's what negative y is. There's a negative in front of this y, so don't lose it. So you have negative y equals negative 4x plus 3/5. I don't want y, negative y, I want y. So what I need to do is divide by negative 1. And what do I divide by negative 1? I have to divide everything by negative 1. All that does is switch all the signs. That is slope-intercept form. How do I graph it? I start with the y-intercept, which would be the letter B. What's the y-intercept in this case? It's actually -3/5. I used a fraction here just to see if anybody would think, oh, I'm doing rise or run. It's 3 and 5. That's not what it is. The y-intercept is -3/5. That leads you to the coordinates of 0, -3/5. Remember I said x is always 0. So my starting point, my y-intercept is right in here somewhere. 3/5 down from the origin, from the 0 mark there. The slope, that's what's in front of the x. That's 4, or 4/1. That means going from your y-intercept, which this is your starting point, people. Always start at the y-intercept. It's your starting point. Then from there, you're going to go rise 4, run 1. Now, I would always go right. If it was negative, I would put it with the top. If there was any negative here, I would put it at the top of the 4, and then I would always run 1, which means go right. We're always going to run to the right. So from this point here, I'm going to count up 4 and 1 right. So I got 1, 2, 3, right about there, 4, and then 1 right. And there's my other point. So I started here, I went to here. I could do it again. I could go up another 1, 2, 3, 4, and 1 right. And that should be on the same line. And then just draw a line through those points there. That's how you graph using slope and y-intercept. Find the slope and y-intercept of the line dx minus 4y equals f. Again, easiest way is probably to get the y alone, so it's in slope-intercept form. If it's in slope-intercept form, I know the slope's what's in front of the x. I know the y-intercept at the end. Excuse me. So let's get the y alone and see if we can identify that. This is what we did last chapter when we solved for a letter. Get rid of your adding and subtracting first. So I've got this extra dx to the left. I need to subtract it over. The f didn't move, so it stays positive. Now I need to get the y alone. How do I get the y alone? I get rid of the -4. And I get rid of the -4 by dividing everything by -4. And I get y equals. Here I've got 2 negatives. 2 negatives make a positive. So what I have is d over 4 times x. dx divided by 4 is the same as d over 4 times x. On the end, I've got a positive divided by a negative is a negative f over 4. What is in front of the x is my m. So my slope is d over 4. And whatever is at the end is my y-intercept. So my y-intercept is negative f over 4. Example 6. Plumber charges $75 to come to your house and then gets $50 for every hour of work that she does. Write an equation to get dollars paid based on hours worked. Well, if you could put yourself in the shoes of this plumber, I would hope that you could say, you know what, I'm going to get $75 for showing up. That's what I start with. If I was going to graph that, that's actually the y-intercept. You're getting $75 just to be there, whether you fix something or not. Then you get $50 for every hour. When you see every or for each or per, that's a good sign that you're thinking of your slope. You get 50 every hour. So in 1 hour you get 50, in 2 hours you get 50 more 100, 3 hours you get 150. What that is if I go 1 hour to the right, I go up $50, which would be 125. This is the line. It's actually a ray, I guess. I shouldn't say it's a line. It's a ray. I shouldn't go into negative territory. This plumber can't work negative hours. The least they could work would be 0. That means that my domain would actually be be 0. I would start at 0 and move up. Okay? My range starts at 75 and moves up. If you want them to move in with you and keep working on your plumbing, they can make an infinite amount of money. Well, as long as everybody's alive. So, but what I have here given you is a slope, up 50, one right. So 75 was your y-intercept. That's the starting amount. The slope was also given to you. That's 50, or 50 over 1. It's really easy to write an equation. If I go y equals mx plus b, it would be y equals 50x, because 50 is my slope, plus 75. Now we're not doing y and x though. I told you to use d and h. So I said write an equation to get dollars paid. So y is what I would get paid. So that's d. Dollars paid is on the y-axis. And then actually down here would be your hours worked. Right? So this is your pay on the y. Hours worked is down here. So it should be 50h plus 75. And that concludes the lesson on slope-intercept form of a line. Thanks for watching. Have a great day.